Hello there, and welcome to Transfer Learning, the best kept secret in the deep learning neural networks area. Now, to really understand the motivation behind this method, let's take a look at some of the facts. To actually train deep neural networks, it takes a lot of memory, it takes a lot of processing power, and of course, it takes expertise and time. So, for example, if you wanted to train on the VGGNet, this is used to identify images. Now, the data size is 1.2 million images, so that's a lot of data. If you take a look at the parameters, it's 140 million parameters. And similarly, if you take a look at deep video, this is 1.1 million videos, and then here you have 6 million sentence pairs. So that's a lot of data and that's a lot of parameters to process. So this is going to take, first of all, a lot of time, a lot of processing power and hardware, and also it's going to take a lot of expertise. So there should be a way to reuse pre-built models and not reinvent the wheel. Let's take a look at how actually humans learn. Now let's go back to learning maths and try to see how we actually did it. Now if you recollect, from grade 1 to 5, we basically learned the basics of mathematics. So let's call this stage 1. So at the beginning of stage 1, we practically didn't know anything about math. Now when we actually entered grade 5, we entered with the knowledge of stage 1. So let's hold on to that thought. So here we learned new techniques, new subjects, new methods, and then we developed knowledge 2 or stage 2, which is basically a combination of 1 and 2. And eventually we go on, and here we learn to apply maths to different problems and so on. In stage 3, we came in with the knowledge of 1 and 2, and then eventually we left with 3 knowledge, which is basically a combination of 1, 2 and 3. So here you get the picture that in grade 5 to 10 you're actually reusing what you learned in 1 to 5, and in higher education you're actually reusing from grade 1 through 10. So imagine if you had to actually learn a new technique to apply to a certain problem, and you had to learn the mathematics from all the way 1 through higher education. That would take an immense amount of time and effort. So a similar principle is applied in transfer learning. So you want to be able to reuse what you can and to apply that to new problems. So one such example is from the math work. So this is an RxNet which has been trained for over 1 million images, and it can classify to 1,000 object categories. So here you're going to use the pre-trained network and fine-tune it for your specific data. So the method is you load the pre-trained data. This is basically the weights and biases. Initial layers, they pick up on the low-level features. And as the layers progress, it picks up more dense features which are actually pertaining to your input dataset. So this is what you want to replace. So you replace the last set of layers and you build in new layers to learn features corresponding to your specific dataset. So you feed in your training images, and then finally you'll be having your own trained network. So obviously this time will depend on how many new images you feed, but this will be significantly less than if you have started from the beginning. For example, here only took about 4 seconds, and they're using a GPU. So this is one of the best case scenarios, but you get the idea. So there you go. Transfer learning is extremely important topic in the deep learning area, and this is something all of the practitioners must understand and put to use.